Algebra 2, Chapter 8, we're getting into our last unit of the year, and we're going to deal with exponents and logarithms. But Lesson 8.1, we're going to have exponential functions, and you can see we're going to fill out a table. And my advice is to use your graphing calculator. We can go to y equals and just get this typed out exactly as you see it. Remember, to get a fraction, we'll go alpha y equals. We're going to say this is 1/5. Close our parentheses, raise that up to the x power. Now, in the past, we've been going with the second window. Second window is the table set feature. Let's bring it back to auto. In previous chapters, we have gone to ask, and you can even have your table start at 0. Make sure your delta table is 1. And if it was on ask, if it was darkened in over here, just go over auto, hit enter, and then hit second graph. We're going to go to second table. And it looks like they want values from -2, so I'm going to up arrow a little bit. At -2, we'd get 25. At -1, you could see we were at 5. At 0, we're at 1. As I raise up to the 1 power, I'll be at 1/5. And then when I plug in a 2, you can see from the table that we get 1/25. Now, I do want to point out to you that, of course, you could do all of this by hand. You could have said in the very beginning f of -2. You don't have to do this on a table. You could simply take 1/5, raise it up to the -2 power, and get all these answers here. Let's go to the back page very quickly. We're going to deal with graphs. And even if we were to take a look at the graph of this function right here, if we did a zoom 6 or a zoom 4, a zoom decimal, you can see that the general shape that you're going to see is really something, as I'm running my cursor over here, something like this kind of a shape or this type of a shape. These are exponential curves. Some variation, you're going to see that x values are always okay to plug in. And as we read this, the graph of this exponential function is shown below. And the horizontal asymptote is a dashed line. So you're going to notice that this right here is a line that your curve will never touch. And your y values will never even be achieved there. It just gets closer and closer to that. First, we're going to be asked to always find the domain. And we're going to be asked to find the range. The domain will be all reals for every one of these problems. What that means is domain is x values. And guys, every single one of these, every single time, you can say that your domain is all reals. That means you can plug in an x value of 2. You can plug in an x value of -1. Any x value is okay. As we looked back on our function here, and if we went to our table, we'd never ever see an error. We'd never say, hey, you're not allowed to plug something like that in. And you can see that your curve will have all x values represented. Now, the range will be the y values. And the range, guys, what you want to do is look for those dotted lines, because they're going to tell you what your y values can be. Now, you can see right here that your curve in blue right over here is going to be underneath this y value, underneath this y value of -1. All these points with y coordinates are smaller than -1. When your curve is underneath, you're going to say y is less than. When you look at this dotted line, you can see this dotted line was by a y value of -3. By way of comparison, look at all these points. Their y values are above that dotted line. So you'd say that all y values are greater than -3 here. So look for your dotted line, find out what that y value is, and you'll either have y being less than that, and then your curve is underneath it, or you'll have y being greater. That's when your curve is above. Okay, as we look at number 4, really a gift question, we're going to go ahead and just use our calculator. We can type in 0.2, hit the caret button, and type in negative 0.25. Just type it out exactly as you see it. We're going to go to the nearest thousandth. That's to 3 decimal places. 1.495. 1.495. And as we look at this next problem right here, that's just going to be parentheses, alpha y equals, so we'll go 5, bring down the 6, parentheses, raise that up to the 1.6 power. We're going to go to 3 decimal places. Here, though, the third decimal place is a 6, but when you look to the right, that number is larger than a 5. Whenever you're equal to 5 or bigger than 5, you got to bump this third decimal place up. Now, another way we can do this is we can, because we're going to the nearest thousandth, say we need to go to 3 decimal places. You can always let the calculator round it up for you. You'd get 0.747. Our last problems involve E. And E is a very special number. E is about 2.71828. It's a very special number in advanced mathematics, and very direct problem here. We're going to type in 245, but you'd wonder where E is. Look where the 4 button is. Just to the left of it is ln, but right above that is E and an X. We're going to go second and hit that button. And then we'll go 0.15. And again, we're going to go to the nearest thousandth. We'd get 284.649. 284.629. Last one, E to the negative 0.5. We'll just very quickly type in second E, type in a negative 0.5, and without too much work, we'll get 0.607. So that's lesson 8.1.